let's dive in with a topic that is very close to my heart, and I believe it bears enormous potential for machining, industrial 3D printing, or as we like to call it, additive manufacturing. And additive manufacturing is already used in the medical realm, in aviation, but for mechanical engineering, there's still a lot of potential to be used. And we have a speaker here today who doesn't have a singular perspective on the topic. He's working in the VDMA and he's making sure that the different relevant players come together. And I'm happy to welcome him here today. Give him a big hand. Rainer Gebhardt, subject specialist at VDMA for additive manufacturing. Good morning. Thank you very much. Thank you very much for being here. Thank you, Sven, for the kind introduction. And thank you for saying that this is a very exciting topic. For 10 years now, I've been working on this. I'm Rainer Gebhardt. I work at the VDMA as a mechanical engineer on this topic, industrial 3D printing. Now, for this presentation today, I came up with new solutions as examples for successful additive manufacturing. This always depends on what we do for it and what does 3D printing mean for the industry, and I would like to give you some examples as well. Now, allow me to give you a quick introduction into our group. Sven already mentioned this. It's very important to have a network, especially when it comes to 3D printing. It is a new technology. At an EMO trade show with machine tools, and when we show additive manufacturing, it can only happen through close cooperation within a chain of working groups. We will look at the different technologies and the added value in a structured way. And in the third part, I would like to give you some examples that are shown in this hall. Some of them you can see here. So it'll be worth it to take the time and to go and see some of the showcases, and you can talk to the companies directly. They will know even more on this than I do, and I'm an expert on this topic. Now, let's get started. Let's look at 3D printing and the VDMA. VDMA is the Association of the Mechanical Engineering Industry, which is why it is important to us to boost a future-ready mechanical engineering sector. And we have 3,600 companies in the VDMA Association, 200 of which came together for a working group on 3D printing. So on the one hand, we have the technology suppliers, the machine tool manufacturers, machine manufacturers, and the partners for filters, for plants, for the entire process chain. And on the other hand, we have those who apply those products, those who play a major role for industrial 3D printing, the industrial market for 3D printing. And this used to be only a research topic, but now it's a reality because of this cooperation. Now, it's always very important to show mechanical engineers what the added value here is. In order to do so, we came up with working groups. One of them is named industrialization. So we have the technology suppliers and those who use their products come together at a table. They exchange ideas and they come up with solutions to problems and think about how they can be successful together, because this can only work if the entire process chain understands what this is about. And last but not least, we're of course always interested in carrying these messages to the outside world, which is why we're here at the EMO. I would like to show you here the size of our network, the member companies. At the top, you can see the technology suppliers. Then we have in the middle machine manufacturers. They produce the material that is used, metal and metal powder. We have companies who are working in the periphery of the machines and those who are active in the middle of that process chain. That's the, and then we have those in the post-process of the chain. I talked to a supplier yesterday and he asked me not to name this as a separate process because we are part of the whole thing, and only if we are one chain chain we can be successful. I cannot have a printed machine tool part if I don't know how to clamp it onto the machine. So all of these have to work together. At the bottom, we have representatives of research, engineering, and design. We have service providers. That's the group in the bottom middle with a lot of knowledge. And all of these are very important partners for each other. And in the long run, the users here on the right, maybe they will not buy these parts anymore because they then have the knowledge to build them themselves in their companies. That might become an opportunity, an option in the future. So it's a great network in our working group. To me personally, it's a lot of fun to bring these people together, and I would like to show you the shares of people that we have. We have suppliers in blue on the right, that's machine manufacturers, so 1/5, the 6%. Then we have research, then we have all of those in the periphery of the machine that have anything to do with technology, and then we have the same amount of users, and that is so very important. We do not want to be a bubble of technology experts. No, we want to carry this into the industry, into the real world, which is why I'm especially happy to have some with us who actually come from the manufacturing side of things, and they cannot be isolated. We all have to work together, and a network like this is really worth a lot. I already mentioned that being here at the EMO as a user trade show, because those who manufacture the things are not worth anything without those who use their products. So it's absolutely great to be here, and EMO brings all of us together. All of the different players come together here at a trade show like this. There's Formnext Technology Trade Show, which happens in November in Frankfurt. We have a conference trade show, Rapid Tech. There's an IMTS. It's very international for the 3D printing world, and I think that we need all of these platforms in order to show the added value and the opportunities of 3D printing and to render them transparent. Here you can see where we're going into the future. This is a survey from earlier this year. The one from autumn is still running. In the next 6 years, you can see that here, that's dark blue. We will not have growth. But in the long run, and this is very typical for this industry, 24 months, that's the lighter blue columns, people really are optimistic, and we hope that this will turn into a reality. This is very important to us for the members of our working group. This is not a quantitative survey with specific numbers, but this is a tendency of what we can expect. AM Power has conducted another survey. They speak about growth numbers such as 14% for growth. In 2028, we would be at 20.2 million if that turns into a reality. There were different prognoses of the past couple of years. The current situation plays a role here, of course. But with looking at 2020, growth was there, that's clear, and we hope that this will be a constant trend for the future. Now, even if this might be nothing new for some of you, I would like to give you a quick overview over the technologies, the experience in the VDMA. It's very important to understand that this is not about one manufacturing process. Those of you who know 3D printing from the industry will love the left-hand column, powder bed fusion 3D printing. It's a very exciting manufacturing process with very nice solution, with high design freedom and high complexity. Powder bed fusion enables metal powder or plastic powder to be melted through, for example, a laser beam, and then creating a workpiece shift by shift. I think I don't have to explain this in more detail. There's a lot of information on that out there. It comes with a high design freedom, and it is also a little bit more expensive, and it comes with more effort because, powder simply comes with many parameters. I will not go into a lot of more detail here, but what's important to me is that binder jetting is nothing new. You use a binder, and by means of an inkjet, you stick the powder pieces together, and it is similar to molding, actually. And this doesn't come with a lot of certification effort because you mold it. You use 3D printing as your design element. Micromat, that's a company around here, over here in the hall, they do something like this, and I will show you an example. Later on, you can binder jet large molding parts with this method. Extrusion, I have a 3D printer at home for melting a type of granulate or filament from it's a plastic filament. It's not very precise, but it comes with a lot of opportunities, and this can be used in order to build large volume parts for large parts and components. The other processes, photopolymer, lithography, I think these are known for, in the dental world, dentists use this. Inkjets can be used for these, for complete parts, through the use of energy. But on the right here, this is important. There's various processes. I personally think that this is one of the growth areas, growth processes, where material is added either directly through kinetic energy or added laser energy. There's various opportunities here. There's WAAM, the wire arch additive manufacturing. This is for the manufacturing of large parts. You can find details with us or out there. For us, it's important the process in the middle. It's a very central process, but understanding the entire process chain on the materials side, the powders or other materials, the preparation, the data preparation at home with me, that's the main factor, actually, because printing itself is an automatic thing, but getting the data ready, that's not very easy, and that comes with a lot of expertise, and the players out there can help you with that. Then the post-process on the right, orchestrating the entire thing, managing data factors such as quality assurance, documentation of the processes, they are very important. Now, at the end, for all of us, it's about getting an added value. Nobody comes here and says, I'm a mechanical engineer and I would like to do some 3D printing. That doesn't make any sense. So we need to transmit solutions, and that is a challenge to us. That's the challenge to us. You can show people processes, and some people will think, that might be of interest for me. You can show them end products where 3D printing played a role, but transmitting the entire story, that doesn't work within 1 or 2 or 3 minutes, and that's very important in order to implement 3D printing. I divided this into 3 categories. First, that's 3D printing with all of the opportunities when it comes to design, and there's very exciting opportunities here for functional integration. For the lubricants, 3D printing can be used for process technology. Less material is used in order to increase efficiency, in order to decrease costs for machine tools. There are exciting examples out there, building a working piece from a working block with 90% of chipping in the end. That's not very great and very efficient, and this can be used in order to improve that. Another success factor for 3D printing is lightweight construction, bionic structures that are available, which is why in aviation this is used massively. At the end, the cost factor for manufacturing doesn't play a big role, and this is actually important. Controllers say, why do you want to do 3D printing? It's very this is expensive. I want to look at the life cycle. If I can save some weight, yes, it'll be worth it. So that's when it starts to make sense. For example, when the energy use can be reduced as well, when cycle times can be reduced in manufacturing for machine tool use, that's also very important. The middle column, maybe this doesn't appear to be measurable for those coming from the finance perspective. There's that flexibility. It gives you the opportunity in prototyping or in developing to coming up with a product a lot quicker. Of course, 3D printing can be used in a decentral way. It comes with logistical advantages. And when it comes to individualization, it comes with a lot of advantages. And you and your products need to find out what the advantages are. For medical technology, it's obvious. Any prosthesis, dental prosthesis, is a major advantage for 3D printing and vice versa. But we often have the experience with customization payoff, and 3D printing can be a decisive factor here. And of course, when you want to adapt a workpiece to an operator or to a process, 3D printing offers you opportunities here as well. I don't need a specific tool that only pays off if I have manufactured 1,000 pieces. From batch size 1 on, 3D printing is worth it. When we talk about the situation that we have and circular economy, for example, service and resilience come in here because we can reduce the costs for repairing workpieces that have been manufactured traditionally, large volumes, milling, for example. 3D printing can be used in order to build up the parts that broke. Print on demand comes in here as well. For print on demand, 3D printing comes with a lot of potential as well. And we have requests from the automotive industry a lot when it comes to print on demand. So there's a variety of topics here that we need to keep in mind. And we hope that 3D printing will gain more and more momentum in mechanical engineering. Now, I would like to give you some examples. This is a company called Micromat. They manufacture machine tools, and they gave us this example at the trade show. They have an 80-kilogram workpiece, a topology-optimized swivel axis that's usually done through sand mold casting. Here you can see some numbers. By means of 3D printing, they were able to clamp a model, and they were able to reduce the mass by 31%. And at the same time, they were able to increase the rigidity by 20%. So these optimization processes, of course, are necessary in the pre-phase. But in the end, I have a binder jetting manufactured mold cast model that can be designed flexibly if I adapt the data accordingly, process data accordingly, and it is used in the real world. It is exhibited here in this hall. It's very fascinating. Company named Gebhardt in this hall. They are exhibiting in this hall. They use wire arc additive manufacturing, which is a process that enables you to manufacture a workpiece at high work rates by means of wire arc. Over here, it's very obvious that this is not milled from an entire part. It is an 83-kilogram block. That was how it was originally done, but this is built shift by shift, and this finished part is weighs only 7 kilograms. especially when it comes to expensive materials. This is, of course, a major advantage. Go and approach the colleagues if you want to learn more about this. This is a tool for stone working. DMG came up with an exciting process. Their machine is exhibited in hole number 2. It is a traditionally manufactured core and a part clamped on top. And this was manufactured by means of powder, melted powder. And this can work within one clamping process on the machine in a 5-axis system. And this leads to less material use. And by means of using a laser process and a powder process to combine various materials, the potential is very high when it comes to functional integration and thermal parameters. I don't have too much time left. This is a cutting tool for stator housings. I think this is part of an electronic engine. A lot of work was put into the pre-phase and to the planning phase. It's very interesting that it has a gyroid structure at the core. There are channels inside, cooling channels. You can see the various, the cutting plates have not been inserted here. And the weight that they were able to decrease the weight of this part, and it was manufactured with a powder bed processing system. We have it exhibited at our stand. It's a very exciting way of processing metal. This has been developed years ago for a laser sintering machine for forging. So there's a working part that spreads the liquid, the fluid, to the top and to the bottom of the forging head, and that leads to the use of less fluid while increasing my productivity. It's an optimized way of forging. This is a rather simple way, a rather simple example. You can see these tiny elements between these black parts and the steel columns. This is a clamping set, and they were able to come up with a very compact way of manufacturing this in one process. And this needs to be discovered first, and this is an example where those who work in the pre-phase and in the post-phase have to work together in a very successful way. I need to get to the end of my presentation. I would like to invite you to use this QR code with your smartphone. All of our members, you can find all of our members and technical applications, examples from the real world. I think we have 50 examples combined here, and most of them are profitable use cases. We didn't want to show you research examples. We wanted to show you examples from the real world so that you know this is real. Additive manufacturing is happening out there. Here you can see our activities, our groups. You can see that we have a sustainability working group, one on machine standards. We work on education. We go into the universities in order to get the mindset of additive manufacturing into the heads of the next generation. And we also want to do that together with machine tool manufacturers who already use 3D printing in a profitable way. Thank you very much for your attention. That is the end of my presentation. I'll be very happy to talk to you again, get some feedback, or come and see us at our booth. Thank you very much. Rainer, thank you very much for this presentation. Right, there's a question here. Do you have a private 3D printer? Yes, I do. You mentioned that. I do too, and I have to mention here, it's actually funny, if you're in this industry for as long as we both have, you think about this every day. Shall I get a printer like that or not? And I'm not an expert when it comes to technical parts, and I didn't pay a lot of money, but after 1.5 years of using that thing, I can tell you, you need that. Everybody should have that at home. But you download the data from the internet? No, I don't. I want to make this very clear. I had an exciting talk from a representative of Autodesk on data fusion. I used Tinkercad for my first self-made parts. And what I would like to ask you, maybe you could give us some more details on the following. This often feels like a mission to inform people. Yes, and especially for machine tool industry, why is 3D printing not automatically named and mentioned everywhere? You can manufacture things that are lighter. Why is that so very hard and slow, that development? I think the understanding of the entire process is simply not very easy to teach. Never change a running system that comes in here. We have forged walls in our workpiece that are super thick, and these workpieces cannot be changed that quickly. And of course, there are also technical challenges, the diversity of the processes and the integration into a manufacturing process. And we need to be honest, there's machine tool manufacturers here who have been building the machines for 100 years, and they know exactly what they're doing. They have optimized their processes. Now this 3D printer comes in suddenly into the production hall, and they need to integrate that. And that is what we started with 10 years ago. We started in the green field. Now we have obviously UA, and we kind of got some machine tool manufacturers on board. But manufacturing processes that need to be adjusted within the entire chain, that's not very easy for us. This has been very important since the beginning of the project. Traditional manufacturing plays a big role, but to combine that with additive manufacturing and making a smooth process from that, that is a big challenge. Certification processes come in as well. But I'm always surprised. We are here in the tool and plant engineering sector. If there's a sector made for this, it's this. We have large batch sizes, small batch sizes. We have customized machine tools. So additive manufacturing can really play a major role there. Right, imagine we have a guest here who has heard about this many times, and he always thought it was very fancy, but he never knew how to actually get started. He has middle-sized batch sizes. Yeah, I would say approach somebody who knows how to do it. At our booth, people approach us who have never heard of this or don't know a lot about additive manufacturing. So we then ask them, what are you manufacturing? Metal, plastics, what are your batch sizes? And then there is other people who can give you advanced information on your use cases. And then you can decide whether that's actually the right process for you. There are service providers who do that. But we like to always tell the people to get actual experts, look at your specific CAD image, your prototypes, then talk to the experts. Then you can come up with new ideas and come up with a lot of great solutions that can provide competitive advantage for your machining. Werner, we are on time. 3 seconds left. Thank you very much. Rainer, thank you very much for being with us. Rainer Gebhardt, Additive Manufacturing. Take a look at it. Thank you very much.